Welcome back. So we are doing now the lesson on measures of location and dispersion. So the objectives of this lesson are for you to understand how to calculate mean, median, mode, and standard deviation. So we have the measures of central attendance, which are mean, mode, and median. Then dispersion, which is the variance, standard deviation. So we are going to be calculating them, but we are going to be doing for sample and for a population. So like I said, measures of location or central attendance is just the mean, median, and mode. So we start with the mean. We call it arithmetic mean. We just add all the values that we have. We divide by their number. So this is the sum of all the numbers that we have. X represent any number starting from 1 to nth number. So this sign is sum of, which looks like an E. Then we divide by the sample size. The population again still is the same, but we add all the figures, then we divide by their number. So then we have the median. Median divides the data into two halves, so the middle number is the median. So if they are odd numbers, like saying 3, 5, 7, you add a 1. You say n plus 1 divided by 2, then you get the middle number. If it's even, you do the same, you add 1, then you divide by the number. So that is, then the mode is the number which is appearing more than others, or is the number with the highest frequency. So without wasting time, let's look at the example. We have our data here with the 2, 5, 8, minus 3, 5, 2, 6, 5, minus 4. So we want to find the mean. The mean, we add all the numbers, which is sum of all numbers, divide by their number. So it's 2 plus 5 plus 8 minus plus minus 3 plus 5 plus 2 plus 6 plus 5 plus minus 4. How many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we divide by 9. Then we get the answer. So that will give us our mean. Then we now want to find the median. So we arrange these numbers in order of size. We can see that the smallest number here is minus 4, followed by minus 3, followed by 2, 2. If it repeats, you repeat also. So it's minus 4, minus 3, like that. So I'm labeling them. The first one is minus 4 up to 9. Then remember, to get the median position, you say n plus 1. So it's 9 plus 1. How many numbers do we have? It's 9. So it's 9 plus 1 divided by 2. Is the 5th position. So I start from the lowest number up to 5. So 5 is going to be my median. So like for median, we arrange the numbers in order of size. We find the median position, then we pick the median. So I think you are following. So this is what we have done. So in case they are even numbers, let's say we have added another number and now they are 10. Now we arrange again in their order. So if we add 1, we get 5.5 position. So where is the 5.5 position? Is 1, 2, 3, 4, 5. 5.5 is between 3 and 5. So we average these two numbers. So we average these two numbers. So that is our then we want now to find the mode. Mode is the number that is appearing more than others. So from this data you can see that 5 is appearing 3 times, so our mode is 5 because it's the one which is appearing more than others. Then we can find the mean of a frequency distribution. So we say frequency times the number or the midpoint divided by the sum of the frequency. We may find again the median of the grouped data. This one is the highest number minus the lowest number of that group, then n over 2 minus the frequency, total frequency before that group. It means we need total frequency, we need to know the width, we need to know the total number. Then LI is the lower limit of that median class. So what is important first is you identify the median class. So for the mode, we have another way again of calculating the mode. Now let's look at the example. It might look scary, but we are using the same data that we grouped from before, and our total was 48. So like you saw that we did the midpoints. 2 and 5, the midpoint was 3.5, the frequency was 3, so nothing has changed there. So for mean, when we are calculating mean, we need the midpoint of a grouped data. 2 plus 5 divided by 2, 3.5, like that. So what we'll be doing is, f is this f, x is this x, so it's f times x, so it's 3 times 3.5, 4 times 6.5, 11 times 9.5, like that. Then we add them, then we divide by their number. So then, so after adding them, you say this times this times this, you're making a column fx. Then if you sum, you get 597. You divide by the sum of f is 48, so you get the mean here is 12.44, so that you don't get lost. Now the median position is, we have got 48 numbers, so if we divide by 2 we get the median position. So 48 divided by 2 we get 24, but this 24 we have to find it from our cumulative frequency column. So for us to get a median for a grouped data, we need to have a cumulative frequency column. So from our cumulative frequency column, we said the median position is 48 divided by 2. So is 24 in 3? No. Is 24 in 7? No. Is 24 in 18? No. In 31? Yes. So it means this is our median class. This is going to be our lower limit. This is going to be our frequency of the group. Then the frequency before is this one, because we are in this group, so before is this. So then we use this formula. The upper limit is of that group is 14 minus 11, so it's, the width is 3 here. N over 2 is 48 divided by 2 is 24 here. Then cumulative frequency before this group was 18, it's here. Then we divide by the frequency of this group is 13. The lower limit of the group is this one, is 11. Then you calculate. So that is the, so we plotted this. So This is our cumulative from the previous. Then now again, this is we use the same data that we did for the mean. Now we may want again to draw a histogram from this. So it's 2 to 5. 2 to 5, the frequency is 3. 5 to 8, the frequency is 4, like this. So if the highest, the highest, the tallest bar there, you can see if you do a cross like this, you go and reach and find the mod. This is how the simplest way to find the mod. You draw your histogram on the longest bar, you make this axis where they meet, it's your mod. So this is the estimate of a mod. So we can talk about the skewness where the data is towards. If it's mean, median, and mode, they are on the same position, so we mean the data is normal. If the tail it goes to the right, we say it is skewed to the right or positively skewed. Here we are plotting three things: mode, median, and mean. So it's skewed to the right. Here it's skewed to the left. So where there is a mean, that is where we describe. It's skewed to the right, it's skewed to the left because the mean is on the left. It's skewed to the right because the mean is on the right. So these two, they are not symmetrical, meaning they cannot be divided into two. But this one, the normal, is divided into two. Now we look at the measures of dispersion. We were talking about measures of central tendency, so we talk about range, variance, standard deviation. So range is just the largest number minus the smallest number. It's easy to compute, but it doesn't give any information that is important. Then the variance, this is for a simple data there. So it's x minus x, the mean. So we subtract the mean from each value, then we square, then we divide by n minus 1. So that's the variance. It's represented by s squared. This is for a sample. Standard deviation, we just do the square root of this. So that's the. Then for a population, still is the same, but we use big N to represent a population, and this we use the sigma sign. For a sample we use the S, but basically the calculation is the same. The population mean we use the mu. That side we say the x bar, but the calculation doesn't change. After getting our sample standard deviation and the mean, if you divide standard deviation by the mean, we multiply by 100, we get the coefficient of variance. Coefficient of variance. So those are the three. Now let's look now for a set of data, then we do the calculations. We have the first set here, so we want to find the range. The largest number is what there is 8. The smallest number is what there is smallest number is minus 4. So 8 minus 4. If you subtract, then it becomes a positive, so it's 12. Then for this data, the largest number is 5, the smallest is 0, so the range is 5. So the range here, we can compare the ranges. If the range is too much, we can say the data is not good because it's spread too much. Now we want to find our mean, so we use this formula. Don't worry about the size of the formula because you'll be provided. So we can square each value here. This is squared, then we get summation of x squared. We can add the sum, then we get the sum of x. Then this is 1 over n. How many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we divide by 9. So the sum of squared is 208. The sum of x itself here it's 26. Then we get the standard deviation. We do the same for the other one. Then now that we know that our symbol standard deviation is 4.08 divided by the mean 2.9, we get the coefficient of variation. Coefficient of variation, this is for first group, second group. So this is a formula now for a grouped data where x is the midpoint, this is f, this is our total set of pairs. So this is our grouped data. So I said the n is the total, so 48. Fx, the midpoint is x, so it's 3 times 3.5, 4 times 6.5, 11 times 9.5, like that. Then we be squaring the x. So we square the x first in a column before we multiply. This one we just say f times x, this times this, then we create a column. We add, remember it's saying sum of. So that is the then we may want to find the quartiles again. So quartiles is just the way that we find the median. We arrange in order of size. It's only that instead of saying n over 2, we're saying n over 4. So the first quarter is 25%, second quarter 25%, because we've divided by 4. So it will become 4 parts. First part, second part. So that is the so from this we can see that if you are to find a lower quartile of this, we arrange again in order of size. Then we say n plus 1 divided by 4. Then we get the 25th position. So it's 1, 2. Between these two, that is where we find our quartile. So it's minus 3 plus 2, we get 1 divided by 2. That's our quartile. In the quartile range, if we find the third quartile, meaning 3 quarters of n, then we found it to be 5.5, the lower quartile minus, so we can find what we call the interquartile